another exponential equation. Now my two bases are 4 and 5. I do not see a common base that I can write both 4 and 5 as a nice integer power of the same number. So I'm going to use logs. So let's solve this and express our answer in terms of the common log this time. Okay. So that means I'm going to take the log of both sides. Log of 4 to the 2x plus 1 equals log of 5 to the 3x. Again, it's corny, but those x's are up there in that exponent position. In order to bring them down, oh, they're so high up, I need to haul over a log to stand on to make myself taller so I can reach them and bring them down. Once I've done that, I can use my rules of logs. So I can bring these exponents down and make them coefficients. Now do be careful, if your exponent has more than one term, make sure when you bring it down you put it in parentheses, because that whole thing, 2x plus 1, is being multiplied by the number log 4. Here this is going to equal 3x log 5. Now I still want to solve for x, but now I have x in two positions. Right now that x is linked to that 1 because they're in parentheses. I'm going to distribute that log 4, which is just a number, okay, to both terms so that I can break apart those parentheses. So I'll have 2x log 4 plus 1 times log 4 is just log 4 is equal to 3x log 5. And now let's get all the x's together on one side. So I've got one side of my equation will have all my x's. The other side won't have any x's. Okay, so I'm going to subtract 2x log 4 from both sides. So we will have log 4 is equal to, these guys aren't like terms, so I'm just going to write it out as a subtraction problem, 3x log 5 minus 2x log 4. Now, since there's an x in both terms on the right, I can factor out that x. So log 4 is going to equal x times 3 log 5 minus 2 log 4. All right, if I want to solve for x, I'm just going to divide by this thing. Okay, so x is going to equal log 4 over this whole thing, 3 log 5 minus 2 log 4. Okay. Now, that's my exact answer. Okay. Generally speaking, if we're not doing an application in these videos, I'm not going to take the time to plug things into a calculator. When we do applications, I will, because that's kind of interesting, because the answer means something to us. Okay. Here, I don't think the decimal approximation is going to be particularly enlightening. But I'm skipping that just in the interest of time, because you guys don't need to watch me plug things into a calculator. You should not skip that in the homework, because the ability to enter that into your calculator and get the right result is important. Just like with the last time, I would need to make sure when I entered it into the calculator that I put parentheses around this if I was writing that fraction as a division problem. Now, some calculators have a fraction mode, so you could actually just enter that on top and you could enter that on bottom so it would look exactly like this. But if you're entering your fraction as top divided by bottom, there are understood parentheses around the top and the bottom. You need to explicitly write them when you're plugging into your calculator. Okay, so do make sure that you're doing that as you do the homework so that you can check that you're getting the right thing, and that way you know that you're using your calculator correctly. Okay, excellent. So let's just try another one. Say I have 2 times 3 to the x minus 5 is equal to 7. Okay. So we've seen some problems where we have just one exponential expression on one side, and some problems where both sides were an exponential expression. Here, taking a log is not the first thing I'm going to do. It would be legal I could take the natural log or the common log. Let's do this one in terms of the natural log. I could take the natural log of both sides. That would be totally fine. Natural log of 2 times 3 to the x minus 5 is the natural log of 7. I hope you can see why that's not useful. It's not wrong, it's true, it just doesn't get me any closer to the answer. In fact, I think it gets me farther away from the answer. And that's because right now I've got this subtraction problem inside of the argument for the log. I don't have a way of simplifying that. Okay. So, logs give me a nice way of simplifying exponential expressions. This isn't just an exponential expression. It's more than that. My exponential expression is just this part right here, the base and the exponent. I'm doing two things to that. I'm multiplying it by 2, and I'm subtracting 5. So before I take a log, I want to make sure that I isolate the exponential expression. Let's write that down. Isolate exponential expressions before you take a log. Okay, so I'm going to add that 5 over. So 2 times 3 to the x is going to equal 12. Okay. Now, at this point, if I did take the log of both sides, I do have a way of simplifying the log of a product, so I could do that. But it's going to be a lot simpler if I just move that 2 over to the other side. Then I don't need to worry about having a log of a product. I could just say 3 to the x is equal to 6. Okay. Let me just show you. If I did take the natural log of 2 times 3 to the x, that would equal the natural log of 12. There's nothing wrong with that. But I can't now bring that x down, because that x doesn't apply to the 2. It only applies to the 3. Okay? So I would have to say this is the natural log of 2 plus the natural log of 3 to the x before I could then bring the x down in front of that term. That's a lot more complicated than just dividing both sides by 2. Okay. So do be aware, if you have a coefficient in front of your exponential expression, isolating the exponential expression does involve moving that coefficient over to the other side as well. And please do not tell me that that is 6 to the x, because that is a huge violation of all rules, well, not all rules of math, but of a very important rule of math, and that's order of operations. Okay. In evaluating this, I would do the exponent first and then multiply. I can't say, let's multiply 2 times 3 and then take that to the x. So I really do need to isolate just what I've circled there, which is the exponential expression. Now, once I've done this, this is quite nice. Natural log of 3 to the x equals the natural log of 6. Now that log allows me to bring that exponent down. So x times the natural log of 3 equals the natural log of 6. Divide both sides by the natural log of 3. And so x is the natural log of 6 over the natural log of 3. And we do not have a way of simplifying that. Okay? Remember, that's one number. Okay? ln6, that's one number. ln3, that's one number. Okay? So I cannot simplify those. We don't have a rule for a log divided by a log. Okay? We have a rule for a log of a division problem, but not for a division problem where the top and bottom are logs. So this is what I would have. And if you're at all tempted to try to simplify that, pull out your calculator. Natural log of 6 is approximately 1.791759469. If I had that on top, I would not be tempted to cancel it with this. Seeing a 6 and a 3, it looks like I should be able to do something, but I can't, because the exponent that would give me 6 is a messy number. And the exponent that would give me 3 is another messy number. They don't have a whole lot in common that I could cancel. Okay, excellent. So that would be our answer. All right, let's have you folks try one. And I'm going to give you one from the homework so that you're getting a head start on the homework as we work through these videos. So this is number 25 from the homework. 4e to the 2n minus 5 plus 3 is equal to 11. So this is one where that's the only exponential expression I have. You're going to want to isolate that exponential expression before you take a log. And in this case, this is from the homework where the book says use either the natural log or the common log. Use the natural log, okay? If a base of e shows up, definitely use the log base e, which is the natural log. Similarly, if a base of 10 showed up, I would use the common log, which is the log base 10. If I have a base of 5, I'm not taking the log base 5 just because of the technology that we have, that most calculators do not have a log base 5 key. So I'm trying to get my answer in terms of one of the logs that I can easily evaluate with technology. So go ahead and work this one out. And since your answer is in the book, do go ahead and once you've got your answer, plug it into a calculator, get the decimal approximation, see how you did. We'll work through it together in the next video, but you can actually check your answer with the book as well.